Softening or conditioning. The process of removing hardness producing salts from water is known as softening or conditioning of water. It is done by two methods, namely external conditioning and internal conditioning. External conditioning involves removal of hardness producing salts from the water before feeding into the boiler, and it can be done by demineralization or ion exchange process. Internal conditioning involves removal of scale forming substances by adding chemicals called boiler compounds directly into the boiler. Scale formation can be avoided by adding sodium carbonate to the boiler water and is used only in low pressure boilers. Scale formation can be avoided by adding sodium phosphate and is mainly used in high pressure boilers. The phosphate reacts with calcium and magnesium salts to give soft sludge of calcium and magnesium phosphates. Trisodium phosphate is used for highly acidic water. Disodium hydrogen phosphate is used for weakly acidic water. Sodium dihydrogen phosphate is used for alkaline water. Calgon is sodium hexametaphosphate, which interacts with calcium ions to form a highly soluble complex, thus preventing the precipitation of scale-forming salt. Calgon conditioning is better than sludge conditioning. Demineralization removes almost all the ions present in the hard water. Demineralized water does not contain anions and cations, while soft water contains sodium, potassium, sulfate, and chloride ions. Demineralization is carried out by an ion exchange resins, which are long-chain cross-linked insoluble organic polymers with a microporous structure. Cation exchange resins are represented as RH2. They contain acidic functional groups capable of exchanging their hydrogen ions with other cations of hard water. Anion exchange resins are represented as ROH2. It contains basic functional groups capable of exchanging their anions with other anions of hard water. This is the demineralization process, at the end of which deionized water is given out. The hard water is first passed through a cation exchange column which absorbs cations like calcium, magnesium, sodium, potassium ions, etc. The cation-free water is then passed through an anion exchange column which absorbs chloride, sulfate and bicarbonate ions in water, thus letting out a demineralized or deionized water. The advantages of this process are that highly acidic or alkaline water can be treated by this process, and the water obtained by this process will have very low hardness. However, the disadvantages are that water containing turbidity cannot be treated because FeMn forms stable compound with the resin. The equipment is costly and more expensive chemicals are needed.